you even have 10 minutes for your presentation, so here's the call. So I will give you 2 minute warning before the end. Okay, are you ready? Okay, let's start.
Good morning, professors. We are GT College. I'm Jackie. This is Justin, Jason, Felix, and Eric. And today I'm going to give a presentation on our research project to predict the performance of Usain Bolt in London Olympics. And to begin, let me talk about the reasons that attract us to this topic. The first is the amazing result done by Usain Bolt in the Beijing Olympics. He broke his old world record with the result of 9.69 seconds. But the most astonishing thing is not his result, but his showboating action within the last 2 seconds of the race, which means he broke his old world record, even he slows down his speed. And after the race, Dutch scientist Ericsson carried out an investigation and predicted that Bolt could have finished at 9.55 seconds without showboating. And in the next year, Bolt really finished at 9.58 seconds in the race in Berlin Championships, and this result fell into the range Ericsson predicted. And then, a question is raised: how fast can Bolt really run? And for these reasons, we developed a few objectives. We determined to apply the mathematics to the real-life situation so that we can answer the question, can Bolt break his world record again in London Olympics? And then is to predict the conservative and optimistic result in the game. And to answer these questions, we have to first develop a mathematical physics model with the following parameters: reaction time, initial velocity, terminal velocity, and coefficient of air resistance. We then apply the Newton's second law, which relates Bolt's motion with the force acting on him, including resistive force due to wind speed, air resistance, and reaction force by the ground. And with the initial conditions, we can derive the solutions of velocity and displacement in terms of time, in which Vt is the terminal velocity that fits our model. And using Taylor expansion, we can express the solution of displacement in short time and long time approximation, so that we can find out the parameters separately using quadratic and linear curve fitting. And here comes to the graphical method. We first investigate Bolt's motion in the Beijing Olympics, and we decided to adopt the data from Ericsson's report. And using the curve fitting, we can find out the parameters as follows. But here's the bad news. After inserting our parameters into the model, we found that our model did not correlate with Ericsson's data very well. But we are not discouraged. We decided to improve our method. And we now work on the case in Berlin Championships. As more data are required, we decide to employ the software tracker to measure the position of Bolt frame by frame. And we call this the video analysis method. And we then obtain the approximate values of parameters using the graphical method I've explained before. But we have to find accurate values of parameters, so that we employ the algebraic method. And let me explain in more detail. This is a snapshot in video analysis method. In Ericsson's research, he used the camera beside the lens for the calibration of Bolt position. However, for our team, we decided to use the male and female hurdle marks for the calibration. And with this already known data, we can accurately find that our data from video analysis correlate with that in the scientific research project done by the Athletic Association very, very well. And we are confident to use our data and develop the table showing displacement versus time of Bolt in the race. And here comes to the scheme of recursive computation. we first find out the approximate value of initial speed u using graphical method. And with algebraic calculation, we can find out the parameters Vt and b. And using Newton's method again, we can have a modified value of u. And let me explain in more detail. The first step is to employ Microsoft Excel for the curve fitting in short time and long time approximation, so that we can find out the approximate values of parameters as follows. The second step is the algebraic calculation, substituting the initial value u into the equation. We can construct a function like this, and using Newton's method, we can find out Vt and b, and substituting it into the equation again, we can have a modified value of u, and this process repeated for a few times, which led us to the following result. After inserting our parameters into the model, we find out that our model correlates with the data very well. And so, we are confident to use our data in other competitions from 2007 to 2012. And for fair comparison, we fixed the value of u and b. And then, Vt was found in each competition. And with the above results, we can have the following interpretation. First, is Bolt's record mainly related to his reaction time and terminal velocity. And since terminal velocity, Vt, is proportional to f minus f0, it is a good indication on Bolt's performance in the race, which means the higher the value of Vt, the better the performance of Bolt. And finally, it comes to our prediction. The first is a conservative prediction by our model. We fix the value of u and b, and we take Vt as that in the qualification round in the Olympic game, because we assume that the performance of Bolt in the final round would be better than that in the qualification round. And we take the reaction time as that in round 1 in the Olympics. Using this equation, we solve for time t, and the predicted record comes to 9.77 seconds. And then, it's our optimistic prediction by our model. We take Vt as that in the final round in the Beijing Olympics, and the reaction time as the best record Bolt had ever made. And the record, 9.66 seconds. And with this result, we can conclude that Bolt will not break his record again in the London Olympics. And here is the final result in the reality. Bolt finished at 9.63 seconds under the tailwind of 1.5 meters per second. Although this result didn't fall into the result with our prediction, we can successfully predict that Bolt cannot break his world record again in the Olympic Games. And in conclusion, we now have a reliable mathematical model, and our questions remain valid. How fast can Bolt really run? And only time will tell. Thank you.